Okay, this is just a real short couple slides to show you how to do calculations with scientific notation and significant figures. Um, Remember when we're looking at the number, like this one only has 3, these zeros aren't significant, they're just placeholders. This one, because there's no decimal, only has 1. This one, the zeros are in between, we count them all, 1, 2, 3, 4, 5, 6. Okay, so again, it's important you need to know the number of significant figures because you need them when you're doing your calculations. Okay, so if I'm doing calculations, if I'm worried about adding significant figures, if you look, this goes 2 past the decimal, this goes 1, 2, 3, 4 past the decimal, and this goes 1. So what I would do is I'd add this number like I normally do, and then I round it so it only goes 1 past the decimal. Okay, so it was 5.36, it went on. I had to round it to 5.3. Okay, the same with subtracting. This goes 2 past the decimal and this goes 4. I'm going to subtract these like I normally do, and then I have to rewrite this. I have to round it so it only goes 2 past the decimal. Okay, 9.22. And again, the reason for that is when I do a calculation with measurements, I have to make sure my answer isn't more accurate than the measurements I took. Adding and subtracting, it's easy. It's the decimal. Whatever one goes the least past the decimal, that's what your answer. So like this one went 2, this one 4, this went 1. My answer can only go 1. Okay. When you're multiplying and dividing, it's the number of significant figures. So like this one has 2 and this one has 4. Well, if I just multiply these numbers together, it's 100 or it's 11.5. Okay. But I can't write it as 11.5 because I can only have 2. So I just write 12. Okay. So again, multiplying and dividing is the number of significant figures. Here I'm going to multiply these numbers, 56.25 times 2. It equals 112.5. But I can only add 1 significant figure. So I'm going to have to round it down to 100. I'll write my zeros, but I won't write a decimal. So this is really close to 112.5, but it only has 1 significant figure. Okay, dividing is the same thing. Okay, you divide the numbers, 98.66 divided by 3.25. You get 30.35692308. You can't write that number because again, then you're reporting an answer that's more accurate than what you took. So this has 4 and this has 3. My answer can only have 3, so I'd write it as 30.4. I just rounded to that. Okay, here's another one, 6.05 divided by 1.1, and you get 5.5, which is nice because that's 2 significant figures. You don't have to do any rounding. Okay, when you're doing calculations like this, they can be really funky because if you think about it, if I ask you what 5 times 5 is, you're going to say 25, but not in significant figures. 5 times 5 is 30. 30, no decimal. Then it would only have 1. But if I write it as 25, it has 2 significant figures. Can't do that. So sometimes it gets a little weird. And don't ever tell a math teacher I told you 5 times 5 is 30. But when you're using significant figures, it is. Okay? Scientific notation, the thing to remember when you're doing scientific notation is you multiply the numbers in front and you add the exponents. So if I was going to solve this one, I'd go 2.3 times 2.45 and I'd get 5.6, and then I'd times 10 to the 9 plus 7 would be 16. Okay, so when doing scientific notation, multiply the numbers in front and then add the exponents. When you divide the numbers in front and you subtract the exponents. Okay, now in this one, I'm going to get a number, like if I take 5.46 times 9.36, I'm going to get 51.1. I can't write it as 51.1. I'm going to have to move the decimal over one more. So what happened was I got 51.1 and it would be times 10 to the third because negative 2 plus 5 would be 3. But then I rewrite this. I move the decimal from 51.1. I make it 5.11. So I make this number smaller. So I make this number bigger. Okay. You got to make sure you're in proper scientific notation. Okay. Here's dividing. Same deal. 4.52 divided by 7.8. You get 0.58. And then you subtract the exponents. Negative 6 minus 9, that's going to be 3. I mean, negative 6 minus 9, sorry, is going to be negative 15. See, I got to write them down sometimes to look at it. But again, if it was 0.58, so I had to move this decimal over. Now, this case, I made this number bigger, so I made that number smaller. So when you're multiplying, you multiply the numbers in front. I mean, when you're dividing, you divide the numbers in front and subtract the exponents. When you're multiplying, you multiply the numbers in front and add the exponents, okay? And then you have to make sure your answer is in proper scientific notation. This one I'd go 7.05 divided by 3.15, and I would get 2.23. And then -3 minus 11 should be 14. Okay? So again, that's scientific notation. We do that every now and then. We don't do it a lot, but you need to make sure you understand how to do calculations in scientific notation. Okay? And then that's that. So that's just something else I wanted to add on to here.